beautiful people, and welcome. In this video, we are talking about simple and compound interest. Now, I'm going to go through all of the definitions, give you all of the formulas, and then we're going to do a few examples. As always, if I make a mistake, I am human. Please let me know where the mistake occurs so that way I may learn from it. All right, let's talk about simple interest. Now, interest, we're talking mostly about money. We're talking about potentially gaining money when you have interest, or you potentially could be paying the money. If you have, for example, a credit card with a high interest rate, you're going to be ending up paying money. So let's talk about the different interests, and if you're choosing your credit card, which one to choose, and if you're investing money, which one you want to invest with. All right. So simple interest, let's start that. It's in the name. It is simple. For an account earning simple annual interest at rate R, the value of the account after T years with principal P dollars originally invested is this. So what does that mean? You have your rate, you have your originally invested principal, which is just the amount you started with. If you're in my class, think of like A sub 1, like what's your initial value? T is in years, and your S, your simple interest, your total is just what's the total afterwards. Now, the simple interest is something that happens one time, like once a year for 10 years, right? So T could be 10 years. It does not happen many times per year. It just happens one time per year. So if you have 10 years, your T value would 10. If you're investing over 20 years, then your T value would be 20. Let's talk about compound interest. For compound interest, it is for an account earning compounded annual interest at rate R with compoundings per year. The value of the account after T years with the principal, which is the original dollars invested. The principal, don't let principal, for me, for some reason, originally when I heard the term principal, I'm like, what the heck does that even mean? It's just the original value, A sub 1. So the difference between simple interest and compound interest gets calculated many times per year. For example, it could be compounded quarterly. It can be compounded semi-annually. So like quarterly, it's 4 quarters, right? So like 4 times per year. It can be calculated for semi-annually, twice per year. So you're talking about a interest rate that is calculated more than one time each year. So if you're looking at your T number of years, so for example, for something that is invested for 10 years, compounded quarterly, that means for 10 years, each year, you get to calculate your interest 4 times. So that's compound interest. Now, continually compound interest. Now, this is the one you want when you are investing money, right? Because it's going to be the biggest payoff, maybe. For an account earning interest compounded continuously. Whenever you see the word continuously, think E. That is the only formula we have with the letter E in it. So if on a word problem, if you see compounded continuously, we're doing a happy dance because you know exactly which formula to use. The rate is still R. The value of the account after T years, right? T years. The time is in years. Principal is just a fancy way of saying original value, or A sub 1. Remember, T is in the number of years. The rate R is sometimes given in a percent. If it is given in a percent, you want to convert that to a decimal. You don't want to plug in any percents in here. So this compounded continuously, meaning every instant, like every instant, I can't even snap my fingers that fast. Every instant, it gets compounded more and more and more and more and more. So you can see why potentially, if you're investing money, you want to have something that's compounded continuously because it just happens nonstop. All right, let's go ahead and do some problems. Mr. Peter borrowed $4,000 at an interest rate of 12%. How much interest is due in 91 weeks if we compounded, like we have simple interest, quarterly compounded interest, and continuously compounded interest? So we're going to find that out first. The first thing I notice is that he borrowed $4,000. So this is your, think A sub 1. This is your original value, or in this case, your principal. At an interest rate of 12%, your interest rate is 12%, meaning we need to convert this to a decimal. how much interest is due in 91 weeks. Now, this is in weeks, keyword. T is in years. So we need to, before we do anything else, we need to convert 91 weeks into years. So let's go ahead and figure out how to do that. Well, we have 91 weeks. And with a quick Google search, we can find out that 1 year is equal to 52 weeks. If you knew that right off the top of your head, congratulations. And so that means 91 weeks is 1 and 1.75 years. Now that we have the quantity of time in years, we then get to continue to solve for our interest. So for our simple interest, using our simple interest formula, again, you can use one or the other. Our starting principal is 400. Just kidding, it's 4,000. 1 plus our rate is 0.12 times our time, which is 1.75. And this is just calculator time, plug and chug, you know. So let's plug and chug this. Here it is. I'm going to do it off screen. Well, maybe no, I can fit it. So I have 4,000. 4,000. I'm just going to type everything into my calculator. So 4,000, 1 plus 0.12 times 1.75. Make sure I have enough parentheses. Press enter. So after 91 weeks, I will have a balance due of $4,840. So again, we started out with $4,000 with an interest rate of 12%. With a simple interest of 12% in 91 weeks, we would owe $4,840. So already you know that borrowing with an interest rate of 12%, I mean, that's $800 out of your pocket for no reason. All right, let's do compounded quarterly. So this is your formula. That is S is equal to your principal times 1 plus your rate over the quantity per year times the quantity per year times the number of years. So what do we have? We have our original starting value at 4,000, 1 plus our rate over the quantity per year. Now the quantity per year is going to be given in a terminology way. Sometimes they'll tell you explicitly this is 6 times per year, like if it's weird like that. But usually it's quarterly, semi-annually. Those are the only two that come to my mind right now, but there are going to be many others. So we have quarterly means quarter 4. So we have 4 times each year, and we are having that rate for 91 weeks or 1.75 years. Remember, your T has to be in years. Let's go ahead and calculate this. I'm going to start off by multiplying 4 times 1.75. That actually gives me 7. I wasn't expecting such a pretty number there. And at this point, I'm going to do the 0.12 divided by 4, and that gives me, and I'm actually going to add 1 to that as well, so that gives me 1.03, where 0.3 is this value to the 7th power. Now I'm going to type everything into my calculator, so 4,000 times 1.03 to the 7th power, and that gives me 4,919.50 cents. Again, don't forget that we are talking about money, so dollar signs. So look at the difference between the simple interest and the compounded interest. Simple interest, we do it once, right? Once a year, that's it, simple. In this case, we do it for almost 2 years, 1.75 years. For compounded interest, we do it multiple times each year. So I compound my interest quarterly, that means my balance is now 4,919. So just because it got compounded a little bit differently, I now am paying an extra $100, again, for no reason, because we are borrowing money, we are in debt. Let's do compounding continuously. Again, anytime you see the word continuously, that is your red flag, glitter in the air type of situation. Continuously means you use the formula with the E. So the formula with the E is S is equal to the principal times E to the RT power. Now, our principal is 4,000. E remains E. Remember, E is just a value. It's a rational value. Our rate is 0.12. Our time is 1.75. We're going to use our calculator. You can just type all of this in if you want. I'm going to choose not to. Actually, why not? I'll choose to do so. I'm going to type in 4,000 times. I'm going to do E, so I'm going to find my E. There it is. Oh, that's not right. Let's go back. E. So hopefully you guys can see that. My exponent is 0.12 times 1.75. Put all of that in a bubble and press enter, and here we have it. And that equals to $4,934.71. So you can see that if we invest $4,000 at 12% interest rate for 91 weeks, with our simple interest, we would owe $4,840. With our quarterly compounded interest, we would owe $4,919. And here we would owe $4,934. So it is most expensive to borrow money with a continually compounded interest rate versus a simple rate. Now, flip your mindset a little bit and imagine you are investing money, meaning you are putting money in and your money is growing. If you want to grow your money, then you definitely want compounded interest if you can get the continually compounded interest. But definitely compound interest is your friend. All right, let's do another example. For another example, it says, how much money do you need to invest now in order to retire with $2 million in 40 years if the money compounds monthly at 8%? Now, in this case, you're not, I guess in a way you are investing money. You are investing money with a 8% rate. So immediately I see 8%, I'm going to convert that to a decimal. This is our initial value. Just kidding. This is not our initial value. This is our ending money. This is what we want. So this is our S. 40 years is our time. So let's go ahead and figure some stuff. And the money gets compounded monthly. So when you're thinking about what formula to use, think how many times per year is this being compounded? So if it's compounding once and only once, you're talking about simple. If it gets compounded multiple times each year, you're talking about a compounded interest. And if it gets compounded continuously, that keyword, then you want the E formula for the continuously compounded interest. In this case, it gets compounded monthly. That means how many times each year? Well, 12 times per year. Just want to spell that out for you guys. Okay, let's talk about formula. Formula time. S is equal to the principal times 1 plus our rate divided by the number of times each year. Number of time each year times the quantity of years. We want an ending value of 2 million. We want to know what our starting price is or our starting investment is. Our rate is at 8%. We are compounding 12 times each year, and we are compounding for 40 years total. So we are solving for our p-value in this example. 12 times 40, that is 480. So I have 2 million. Be careful with losing some of those zeros. And I'm actually going to solve what's in here. So I have 1 plus 0.08 divided by 12. Be careful with how you're doing this. Make sure that your fraction is in parentheses. Enter. Now, do not simplify. Whatever you do, do not simplify. Write everything out. If you start simplifying now, you're going to lose a lot of money. Don't do that. So you're going to raise that. So immediately all I'm doing is I'm raising that, which is my caret, to the 480th power. And again, just keep it as it is. Don't touch it. Yes, you can abbreviate for your work by writing down what your computer tells you, but don't touch it on the actual screen here. So now I'm going to do 2 million divided by this value. So this is going to be tricky if you don't have like the calculator that I have, but what I like to do is 2 million. You can't retire on $2,000, unfortunately. 2 million, make sure you get enough zeros in there. 1, 2, 3, 1, 2, 3. Okay, 2 million divided by, and I'm going to go up here and I'm going to grab that number. Notice how what they show me and what in reality it is are two different things. So you want to get as most accurate number as you can. Press enter. And again, here we have it. So you want to start with $82,394.80. So again, if you want to invest at 8% and retire in 40 years with $2 million, I mean, you have to invest almost $1 million, right? Would that be $1 million? No, that's not $1 million. 82,000, not a big deal, right? I kid, 82,000 is a lot of money. All right, let's try this. What if we have 45 years? So how does this change? Well, the formula is the same. We are still solving for P. However, now everything is basically the same, but now instead of 40, we have 45 years. So everything again stays the same. Some of the numbers you can steal off from the previous example. 12 times 45, that is 540. And I'm going to quickly type this into the calculator. I have 1 plus 0.08 divided by 12. I'm going to do, so here I am. I'm going to raise that value to the 540th power. And again, I'm keeping this value. I am writing it down just in case I lose it. But you don't actually want to use those values. You want to use as much, accurate numbers as you possibly can. Oh, I shouldn't be writing that. That is 336.1636. I'm going to divide 1636. And again, I'm typing in 2 million divided by, and I'm grabbing the number. And notice a whole lot more digits than what it originally gave me. And so the principal is 55,340.20 cents. I want to point something out. This is why investors or money savvy people encourage young kiddos to invest. This is like the most important thing for you guys that I can recommend for you. Look at what we have. In 40 years, let's say you want to retire with $2 million and you want to retire in 40 years, whatever age that may be. You just need $2 million for your retirement. So if you start at 8% interest and you have 40 years before you wish to retire, you're going to have to invest a total of $82,000. Now, what if you had an extra 5 years that you wish to wait? So if you started at a younger age to invest, you have more time, theoretically, you have more time before your retirement age. So the longer you have for that money to sit there, the less money you have to start with. I mean, just in 5 years, you go from having to invest $82,000 to $55,000. Now imagine if you had 50 years. Like imagine if you had 50 years or your percent was greater for your investment. So play around with monies. I'm going to go ahead and link a few videos that I feel are very important for you to watch if you are in my class. If you're not in my class, there are so many investing videos on YouTube. Watch all of them, learn as much as you can, get books on investing, invest now while you're young, so that way you just put the money in and you don't have to worry about it, and when retirement happens, you're set. All right, beautiful people, thank you so much for watching. I will see you in my next video. Bye.